Welcome to the PHYS 101 tutorial today. Today we're going to cover the one-dimensional motion discovered by the class this past week. And the first question is, when you drop a rock off a high cliff to the sea below, when the rock is several meters below you, you drop a second rock from the same location with the same initial velocity. So there is a rock, there is a cliff, and below that there is sea. And you throw a rock off from the cliff with an initial velocity, let's say v0, and that's rock 1. And a couple seconds later, you drop a second rock from the same location and with the same initial velocity. So the second rock would probably go the same initial velocity. And before we start solving the question, let's assume that this is like the downward direction is positive. It's very important to set the sign, declare what side, like what direction is positive and what direction is negative, to avoid confusion. And yeah, so we set the downward positive, so G would be positive 9.5 meters per second squared. And the distance, the separation between the two rocks that we are looking for, let's say D, the separation between the two rocks, that would be the distance traveled by rock 1 minus rock 2. And let's find that out by two different methods. So method 1. Let's try with more graphical method. So that way we can draw a VT graph. Because there's only initial velocity, and then the only force acting on the rock is gravity, and gravity is a constant. So from the initial velocity, it is going to have a linear shape. So there's starting point v0, starting initial velocity, and then it will increase linearly. And the slope will be what? G equals to 9.8 meters per second square. And then a couple seconds later, the person is dropping the second rock with the same initial velocity, and the condition's the same except that the second rock's dropped like a little later than the first rock. So it will have the same slope, and the area, the distance between the two rocks, that would be, let's say at like a random point like T1. The area, the shaded area would be the separation, aka the distance, and as you can see, like as the time goes by, the area will get larger. So that way we can see the distance between the two rocks increases as they fall. So answer 3 would be the correct one. But now let's try more like algebraic, more numerical way. There were 3 formula that we covered in class, that D equals to V0t plus 2 like 1/2 AT squared, or v squared minus v initial velocity squared is 2 times acceleration times the distance. And then the last one, v equals to the current velocity is equal to the initial velocity plus a plus t. The acceleration times the time. So because we're looking for the distance, maybe it will be easier to use either first one or the second one, because the third one, it does not have velocity in there, the distance in there. So let's take D out. Let's say D1, the distance traveled by the first rock, is V0t. V0 times the time, whatever time that is, plus 2 1/2 times g plus t squared. And the distance traveled by the second rock, it would be initial velocity the same, and the t minus the time difference. The time difference between the dropping of the second rock and the first rock, plus 1/2 times g plus t minus t prime squared. And the separation between the two rocks would be d1 minus d2 equals to v0 times t prime plus 2 1/2 gt squared minus t prime squared. And that would be the separation between the two rocks. And v0 is positive, time has to be positive, 1/2 in g is positive, and t is the time that the first rock was traveling compared to the time that the second rock was traveling. The difference has to be the positive, right? And because the whole thing is positive, we have to say the separation is positive, and we can see that this is only going to increase as time goes by. Thus the number 3, the option saying that the separation between the rocks will increase as they fall, that is the correct option. And if anyone has any other ideas how to solve this question easier, or has any questions, feel free to ask.